2.3, Objective 2. The student will be able to identify and use properties of quadratic functions and their graphs. So one of those properties is intercepts. What are the intercepts? Find the x and y intercepts of this. Okay, so what's the method with that? How do you do that? Take 3 seconds and think about how do you find the x and y intercepts of a given quadratic function. X-intercepts, the method for that problem is set f of x equal to 0. Okay, so maybe it's starting to come back to you now. You know, we remember from way back when we were you know, just learning about lines and stuff. Well, here's a line, okay? And how do you find the intercepts, the x-intercept and the y-intercept? Well, it was set y equal to 0, solve for x to get the x-intercepts, set x equal to 0, solve for y to get the y-intercepts, or y-intercept. Of course, y is f of x. Y is always f of x. So it's no different for quadratic functions. To find the x-intercepts, we have to set y equal to 0 and solve for x. And then f of x equals 0, then 0 equals negative 3x squared plus 6x minus 1. Now we could solve this by completing the square, but we will go ahead and solve it by using the quadratic formula, with a equal to negative 3, b equal to 6, c equal to negative 1. And you throw all those into the old quadratic formula, right? If you have a function, if you have a quadratic equation of the form ax squared plus bx plus c equals 0, then x equals minus b plus or minus square root b squared minus 4ac all over 2a. Substitute all the numbers in and then work out the arithmetic. Well, we could go to the calculator at this stage here. If you're going to do that, you absolutely have to have parentheses around the bottom, and really you want parentheses around the top and bottom for safety's sake. Or you could just do some arithmetic with that and simplify it. Negative 6 plus or minus, inside the radical, under the radical, you have 36 minus 12. You got an odd number of negatives there. So 36 minus 12, which are 24. 2 times negative 3 or negative 6. Go to the calculator to get these two numbers. So x-intercept, there's going to be one barely above 0, so barely to the right of the origin, and then 1.816 will be just a little bit to the left of 2. So we see two intercepts, two x-intercepts like those, and of course we can imagine this parabola calculator, this graph. It's got a negative. We could input the function. Already the curve is forming in our lines, and there's our two intercepts, the 0.1 whatever it was and the 1.8 whatever it was. There are the two x-intercepts. So the graph does confirm our work with the quadratic formula. To get the y-intercept, we set x equal to 0, solve for y. And so we set x equal to 0. Of course, automatically we realize that it's going to be just this number right here, negative 1, because you set you let x equal 0, that's going to blow up the first term and the second term and leave just this -1. And that is what y is when x is 0. And so 0, -1 is the y-intercept. Generally, here are some properties. So we are given a vertex form of quadratic function, a times the square of x minus h plus k. A not equal to 0, then you have a parabola for the graph. And second degree or quadratic functions always do that. And you know if the lead coefficient is positive, you have an upward opening parabola. And first example you learn of that is of the quadratic parent function, y equals x squared. A less than 0, like the one we just did, right? The one we just did, we had a equal to -3. -3 is less than 0, and the graph opens downward. The vertex is hk, and to get the h, of course, you got to change the sign of the number that you see in here because of that minus sign. The axis of symmetry is the line x equals h. Okay, so this is the vertical line that determines the left-right symmetry of the parabola. A parabola is always symmetric about its axis, and so since the it has to go right through the vertex, the axis of symmetry, the vertical axis of symmetry, the vertical line that determines that symmetry has to go right through the vertex, hk, so it has to be the line with equation x equals h. So if a is positive, then there's a minimum value, right? This one here has a minimum value, basically 0, but it's k, you know, whatever the height of the minimum value of the parabola is, the lowest point, that's where your min is. It's going to be that constant right there. Otherwise, you have a maximum. So if -3 is the lead coefficient, as we've just seen, there is a maximum value of the function. There's a highest point, not a lowest point. The domain for a quadratic function is always the set of all real numbers. So you see the 2 right there, you know you've got a quadratic function, and that tells you that automatically the domain is, interval notation, -infinity to infinity, set of all real numbers. Range, well, if it's like the one that we just had with -3 as the lead coefficient, then that's the top. That's the greatest y value. And so the set of all y such that y is less than or equal to k is going to be that range, the set of y values for that function. Of course, that's going to be greater than or equal to if the lead coefficient be positive. And so again, here's our graph, and the y values top out, in this case, at y equals 2. So for this, the range was set of all real numbers y such that y is less than or equal to 2. And of course the domain is the set of all real numbers. And again, on that axis of symmetry, the axis of symmetry, which is this vertical line right here, is the line x equals 1, because it went right through the vertex, which was the point 1, 2. In general, vertex HK, whether the parabola be upward or downward opening, if upward opening there's a min, if downward opening there's a max, and for lead coefficient greater than 0, you have your upward opening parabola, and lead coefficient less than 0, a downward opening parabola. Solve the quadratic inequality negative x squared plus 5x plus 3 greater than or equal to 0 graphically. To solve anything graphically, and it's important that you understand this because it's a powerful way to understand what you're doing with the algebra. To solve anything graphically, it's always okay, so we're talking about how to solve graphically an equation or an inequality. One, graph, not gaff, that is a gaff. Graph the left side to graph the right side. Of course, the right side here is just 0. So you'd be graphing the line y equals 0, in other words, the x-axis. The x-axis, you can imagine that horizontal line, right? It has equation y equals 0, doesn't it? Step 3 for the method of solving by graphing is look at points of intersection. Look at points of intersection. This inequality, negative x squared plus 5x plus 3 greater than or equal to 0, holds for those values of x for which the graph of f of x is at or above the x-axis. Okay, so let's break that down. The graph of f of x is at or above the x-axis. So the graph of f of x, well, that's a curve. It's actually a parabola, isn't it? The graph of f of x. Because this is f of x right here. So this curve that we see on the left side, at or above, well, that's the greater than or equal to. At or above. The curve is at or above the x-axis. X-axis. The curve is at or above the x-axis. This happens for x between the two x-intercepts. So here are two x-intercepts that you'd get if you graph this using your graphing calculator. And so we can see that for these x values in here, the curve is above the x-axis. Outside, over here, to the left and to the right, the curve is below the x-axis. But in the middle, the curve is above the x-axis. Okay, it's above sea level. And we do include the intercepts, so this number here, which is a little bit draw that again. This x-intercept, which is a little bit to the left of the origin, that's going to be included, whatever number that is. And this one over here at, let's see, 1, 2, 3, 4, 5 plus, that's included, whatever that is. And all the numbers in between are included. And that's the set of x values that satisfy the inequality. So the solution set for the quadratic inequality approximated, doing it graphically, so you're allowed to approximate, is this compound inequality, negative 0.5414 less than or equal to x less than or equal to 5.5414. And in interval notation, we can put the whole thing in brackets separated by a comma. And so that's